Hello my dear students, welcome back to my classes. In my last video, I taught you about the quadratic equation, and which part I have taught? The part was a quadratic equation solvable by using formula. Okay, and I have derived that formula. So just to remind you, I am explaining again that if our last concept was, suppose general form of quadratic equation was x square plus bx plus c equals to 0. Okay, where a not equals to 0. This is very important part, I told you repeatedly. Then we have derived the formula that we can direct calculate the value of x. Okay, that means we can directly calculate the roots. So roots was x equals to minus b plus minus root over b square minus 4ac by 2a. This was the last concept, that, and you have to memorize this one also. So we get two roots from this direct formulas. Okay, and two roots are minus b plus minus is there. See, observe properly. Then minus b plus minus. For if we use plus, then we will get one roots, and for minus we will get another roots. Understood? Today in this class I am going to discuss about the nature of root. Nature of roots means, without solve a quadratic equation, nature of root means we will discuss about nature of roots. Nature of roots means we have to check that roots are, yes, we will check that roots are equal, roots are distinct, roots are real, roots are imaginary. If roots are real, then which kind of real? Roots are rational or irrational. Understood? So we have to check this type, this nature of the roots, that roots are equal. First thing, we have to check this one. Roots are distinct. Roots are rational. Next, roots are imaginary. Rational or irrational. Okay. Okay, we have to check the nature of this type of roots, that roots are equal, roots are distinct, roots are rational or irrational, roots are imaginary or not. So suppose I am considering an example that I am considering here a quadratic equation, x square minus 5x plus 6 equals to 0. Then the roots are, you will, after solving you will get the roots, that x equals to, okay, I am solving here, then x square minus 3x minus 2x plus 6 equals to 0. I am solving by the factorization. Okay, x square, if we take common x, then it will be x minus 3 minus 2 common, then x minus 3 equals to 0. Therefore x minus 3 into x minus 2 equals to 0. Therefore roots are one root will be x equals to 3, another one will be 2. So roots are 3 and 2. Here roots are real, and see, 3 and 2, these two are distinct numbers. Okay, so in this case, after solving we get to know about the nature of the roots. So is it only one process to find out the nature of the roots? No. We can find out the nature of the root without solve the quadratic equation. Okay, I will discuss it now in my class. Is it clear? So you have to memorize this one, that x equals to minus b plus minus root over b square minus 4ac by 2a. So before discuss of my main topic, I would like to recall all the concept about number theorem. Number theorem means, hope you can remind then what is rational number, what is irrational number, what is imaginary number. This is new for you, imaginary. Okay, you are not habituated to this term, that imaginary number. What is imaginary number? You don't have any idea about imaginary number. Okay, so first I will discuss about the number theory, this number part, that when does a number is called rational, when irrational, when imaginary. I know most of the students know about this, but this class is for all kind of students, so I have to, this is my duty to recall all this information. Okay, so let's go. First of all, you have to know about natural number. Okay, suppose you all of you know which numbers are called natural number. Natural numbers denoted by this kind of n, and natural numbers are 1, 2, 3, 4 dot 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 dot. These numbers are called natural number. Understood? Next, W denoted by whole number. This is including 0, 0, 1, 2, 3, 4 and dot dot. These are whole numbers. Okay, this is set of all natural. This is set of whole numbers. Next, integer. In your book, set of integer is denoted by I, and in standard higher mathematics book it is denoted by Z. You can use any one number. So integer means 0, plus minus 1, plus minus 2, plus minus 3 and so on. What is plus minus 1? Plus minus 1 means plus 1 and minus 1. Okay, so this is set of all integer. Next, important part is rational. Rational set is denoted by Q. Okay, and rational number means those numbers which can be expressed in the form I am writing in sentence. Okay, it will be better, it will be easy to you. The numbers which can be expressed in the form which can be expressed in the form P by Q, where now we have to introduce P and Q. Okay, which kind of number can take the position of P and position of Q. Okay, where this is very important part, where P and Q are integer. P and Q are integer. Where P and Q are integer. Okay, where P and Q are integer, and one more important part, that Q not equals to 0. Understood? Q not equals to 0. Okay, so read the line. This is very important. The definition of a rational number. So the numbers which can be expressed in the form P by Q, that means something by something, that means in numerator is a number and denominator is another number, where the number of the numerator and denominator should be from are integers. P and Q must be integer and Q not equals to 0. Now a question can arise in your mind that why you have considered here Q not equals to 0. Okay, we have considered here Q not equals to 0 for actually if I ask you that what is the value of 0 by 5, what is the meaning of this? We have to divide 0 by 5. Okay, so 5 into 0 means 0 itself, so this complete the division process and the answer is 0. Understood? But if I am asking you that what about 7 by 0? What is the meaning of this? The meaning of this, we have to divide 7 by 0. Is it possible by it is possible to calculate the value? No. That's why 7 by 0 is undefined, not 0. 7 by 0 is undefined in mathematics. Understood? So 7 by 0 is undefined. That means which cannot be defined. So this is undefined. Undefined number. Okay. So if we consider here Q equals to 0, then this number will be undefined. That is why we have to consider here Q can't be 0. Okay, so this is the main definition, but some standard books, some foreign author are using Q greater than 0. Okay, in the place of Q not equals to 0, they are using Q greater than 0. They are using this part. I am writing here that they are using, in the place of Q greater than 0, they are using in the place of Q not equals to 0, they are using Q greater than 0. Okay, some reason is there why they are using Q greater than 0 to make this uniqueness. That's why they are using Q greater than 0. Okay, we can use anyone since you are students of lower class, so you can use Q not equals to 0, but it will be better if you are habituated with Q greater than 0. Understood? I am explaining now that why they are using Q greater than 0. Q not equals to 0 and Q greater than 0, there is a huge difference. Okay, actually in simple words, the denominator can't be 0. Okay, the reason is this: if denominator comes 0, then it will be undefined. Is it clear to you? Okay, so why they have considered that Q greater than 0? I am explaining you. This part less important, but in this chapter the definition of a rational number is very important. Okay, first I am considering some example of a rational number. Okay, I am erasing the top portion. Hope you have all of you have noted down this part. Some examples. Suppose I am asking you that 2 by 5, is it a rational number? Clearly this is a rational number. Why? See, this is of the form P by Q. Here this is P and this is our Q. P means here 2 and Q means here 5. So clearly this is rational. Is rational number. Okay. So what about 5? Only suppose I have considered only 9. if I consider the number 9, then what about 9? Is it rational or irrational? Yeah. So what is the definition? If we can express this number 9 in the form p by q, so we have to try to express this number 9 into the form something by something. If it possible, then we can say that it is a rational number. Is it clear? So I am trying to express it. 9 can be written as 9 by 1. Is it? So we can express here that 9 equals to 9 by 1. So this is our p, this is our q. So this is must be a rational number. This is must be rational. Oh, sorry. If you expressed a number into the form p by q, this is not enough. You have to check that those p and q are from integer or not. Here 9 is an integer and 1 also an integer. So this is a rational. Okay. Now what about 0? Most important part. So 0 can be written as again 0 by 1. Okay. So here this is also rational. Why? Here p equals to 0, q equals to 1, and the restriction is q not equals to 0 or q greater than 0. Okay. And I am explaining later why we have considered here q greater than 0. Why they are considered. Okay. So q equals to 1. Clearly 0 and 1 both are integers. So 0 is means this 0. This 0 is a rational number. A rational number. Is rational. Now one more example. What about, then since 9 is rational, so all the previous set, that means all natural number, we can say that these are rational number also. Why? Natural number means 1, 2, 3, 4, 5, 6. Or each number can be expressed into the form p by q. How? Just we have to consider the denominator as 1. Clear? Suppose I am considering 5. 1, 5, 7, 12, all these are natural numbers. We have considered some natural numbers. So we can take the denominator as 1, 1, 1. So all the numbers converted into the form p by q, where p and q both are integers. So all the natural numbers are satisfying the form of rational. So these are all numbers are rational number. Clear? Now what about minus 3 by 5? What about minus 3 by 5? Is it rational or irrational? So look at the board. Minus 3 by 5, this can be expressed in two ways. How? One way is minus 3 by 5 and another way is 3 by minus 5. Okay, minus 3 by 5 means also minus 3 by 5, and 3 by minus 3 by 5 means 3 by minus 2. That means we can consider this minus with numerator and with denominator also. Actually these two both give us the same result, minus 3 by 5. Okay, so we can express the number into the form p and q. Here for the first case p equals to what? For the first case here p equals to minus 3 and q equals to 5. Okay, and here p equals to 3 and q equals to minus 5. Clearly here for the first case minus 3 is an integer, 5 also integer. So this is a rational number. Okay, we can express into the form p and q. And for the second case 3 by minus 5, it is also into the form of p by q, where p and q both are integers. Okay, so ultimately this 3 by 5, this number is rational. What? Rational number. Okay, rational number. Now question arises, suppose now you will get the answer that why foreigner authors use q greater than 0. Okay, for this condition q greater than 0, we will get the unique expression of p by q. Okay, if only suppose I am in exam time, I am giving you a question that is the number minus 3 by 5 a rational number. Okay, if minus 3 by 5 is a rational, then find the value of p and q. Or suppose I am asking you that minus 3 by 5, if minus 3 by 5 is a rational number, then it can be expressed into the form p by q. Next my question is find p and q. Okay, now in your mind there is have that q not equals to 0, this condition, and on the basis of this condition, suppose two students are there, one student expressed minus 3 by 5 into this form, that minus 3 by minus 5, then his answer will come p is minus 3 and q is 5. Another one student, suppose he has expressed minus 3 by 5 into this 3 by minus 5, it is also true, then his answer will be p equals to 3 and q equals to minus 5. So this is one question, but two students solved into different, and they gets to different answer. His p equals to minus 3 and the second student's answer p equals to 3, and first student q equals to 5, q equals to minus 5 for second student. Is it clear? Why this problem occurred? Why it happened? Why did it happen? Since student knows that q can't be 0, that means q not equals to 0, but if they are habituated themselves with q greater than 0, then they will get unique answer. How? When they will be habituated with q greater than 0, that means denominator can't be negative. Q greater than 0 means what? The p by q and p and q both are integer and q greater than 0. Then this q, if this is the real line, suppose this is 0, then it can't be 0. It can't be 0. But if they are habituated with q greater than 0, that means q can't be a negative number. That means if in his mind it is already be there that q can't be negative, then they will reject this form. Why? Since q can't be negative, here q is negative, then each and every student of the class will get the unique expression of p by q, and each and every student will have the same answer, that p is minus 3 and q is 5. Understood? For this unique expression, they are using q greater than 0. Hope you understand the thing. Okay, so this is the concept of rational number. Okay, now I would like to consider some more examples on a rational number. Okay, let's go. Suppose I am asking you, then what about root over 9? Is it rational or irrational? Suppose you have to check that root over minus 9 is a rational number or irrational number. Okay, so just remind the definition that a number is said to be rational if it can be expressed in the form p by q, where p and q must be an integer with q greater than 0. Nowadays onwards, we will be habituated myself with q greater than 0. Okay, it will be better. Otherwise, you can keep in your mind that q not equal to 0. It does not matter. Understood? Okay, root over 9. So let's try to express root over 9 into the form p by q. So root over 9 means this is nothing but 3. You know the square root of 9 equals to 3, and 3 can be written as 3 by 1. Okay, so we have expressed here root over 9 equals to 3 by 1. So here we can express root over 9 by into the form p by q, where numerator and denominator both are integers. So it must be a rational number. It must be a rational number. Is it clear? Now what about root over 16? Same thing, root over 16 means 4, we know, and 4 can be expressed as 4 by 1, and it is also rational. What about root over 3? Now this is the question. What about root over 3? Some students will say that, sir, we can express this root over 3 into the form p by q. How? We will give the denominator 1. They will say that, sir, we can use that root 3 by 1 means also root 3, sir. So we can express it into the form p by q. So it is rational number. But the answer is wrong. Absolutely wrong. Why? I agree with you that root over 3 can be expressed into the form root over 3 by 1. You can express into the form p by q. But you have to check that p and q are integer or not. Here p means what? Here p means this is our p, and this denominator, this is q. Here both p and q are integer. The denominator is integer. 1 is integer, but root 3? What about root 3? Root 3 is not an integer number. Is it clear? Why? In the set of integer, only numbers are 0, plus 1 minus 1, plus 2 minus 2, plus 3 minus 3, plus 4 minus 4. These numbers are integer. But root 3 is not a member of integer set. So root 3 is not an integer. So you are able to express root 3, this number, into the form p by q. But here p and q both are not integer. And there is no way to express this number root 3 into the form p by q, where p and q are integer. So we can conclude that root 3 is not a rational number. This is not a rational number. Not a rational. That means irrational. Irrational number. Okay, a number is called irrational if it is not rational. Since it is not rational, so it is irrational. Did you get the idea? So in the case of root over 16, we are able to express into the form p by q. But in the case of root over 3, we can't express into the form p by q. Why? Since root 3 is not a perfect square number. That means inside the 3, the number is there. It is not a perfect square. That's why we are unable to calculate the value of root 3. Since inside the root over 16, root over here 16 is there, and 16 is a perfect square. Perfect square means the number which is square of a number. Here 16 is square of 4. Here 9 is square of 3. So in the square root, if a perfect square number is there, then that number must be rational. Okay, and in the square root, it is very important number. Suppose in the square root, inside the square root, if a perfect square number is there, perfect square number, if inside the root a perfect square number is there, then it will be rational or irrational. If perfect square number means 9, 16, Since inside the square root perfect square number is there, then you can compute the value of square root. Whatever value will come, a number will come, and that number can be expressed into the form p by q, like root over 9 and root over 16. So if inside the square root perfect square number is there, then this number must be rational. That means we are able to express the number into the form p by q. So it must be rational. Okay, if this happens, then it must be a rational. But what about root 3, root over 5, root over 7, this number, root over 5. Now 5 is not a perfect square number. Understood? Then what about root over 5? Root over 5 can't be expressed into the form p by q, where p and q are integers. So root over 5 also a irrational number. So in the case of square root numbers, easily we can identify that which one will be rational and which one will be irrational. How? We have verified this part, but inside the square root, suppose the number is there which is not perfect square, not perfect square number, not perfect square number. Then what about this number? What about this number? Then it will be rational or irrational. See, root over 3. I am considering one more example, then you will get the idea that in the case of, suppose I am considering root over 5, root over 7, root over 13. Suppose I am root over 13. Then what? Root over 13 can't be expressed into the form p by q, since root over 13 is not a perfect square number. That means there is no value of root over 13. You can calculate the value of root over 13 only by approximation value. Is it clear? So in the square root, if not perfect square number, then it must be irrational. Irrational. It must be irrational. Understood? Hope you get the idea. When does a number which are in square root or a square root number, whether rational or irrational, we can check by, if inside the square root the number is perfect square, then it must be rational. If it's not a perfect square number, then it is irrational. Now, then what about? Now anyone tell me? Anyone could give me the answer that what about root over 36? See, this is the square root number and here root over 36. Means inside the root there is 36 and 36 is a perfect square number. Why? 6 square means 36. So root over 36 equals to 6. That means it is rational. So to get a rational, we must have a square root number inside the square root. Is it clear? We must have a perfect square number inside the square root, and in the perfect square root, if a not perfect square number is there, then it is irrational. Is it clear? And one very important properties are there, that sum of rational is rational, sum of irrational is irrational. If you consider a rational number and another one irrational, then rational plus irrational itself a irrational. Is it clear? Suppose root 3 is rational, root 3 is irrational, and 2 is rational. This is rational, and this is irrational. So ultimate, this is also a number, root 3 plus 2. This by both, this is a number. So what about this number? This number will be a irrational number. Okay. So rational plus irrational means irrational. Rational plus rational, rational. Irrational plus irrational, again irrational. You can check by yourself. It is very easy process. Hope you have got the idea. Okay. You can note down this part, these two parts. Next, concept of rational and irrational. Hope you get the clear idea that when does a number is called rational and when does a number is called irrational. Okay, this is very informative and you have to keep in your mind. Next, you have to know, I am going to introduce the concept of imaginary number. This is also very interesting number, imaginary number. Okay, so let's go. What is imaginary number? Sorry. Imaginary number. Actually, the journey of imaginary number has been started from square root and from a problem also. Okay, actually the mathematician first faced a problem. After that they are thinking about their solution. Okay, first of all they faced a problem. After that they are think about the solution of the problem. Okay, which problem occurred so that a new branch of number established? Which problem? First I will discuss the problem from which the journey of imaginary number has been started. Okay, very easy. You can also realize the problem. Hope you can realize that yes, this is the problem. So let's start. Suppose I am asking you that what is the value of square root of 9? What is the value of this square root of 9? I am sure then all of you will give the same answer. Okay, and the answer is obviously 3. Okay, is it clear? But if I ask you that what is the value of root over minus 9, what about this? What is the value of this? Anyone is able to give the answer? Okay, let's try to find out the value of root over minus 9. We know how to calculate the value of root over a root over number. Okay, suppose root over 16 is there, then easily we can write 4. Why? Since if you multiply 4 and 4, then we will get the number which is inside the square root. Okay, which is inside the square root. We have written here root over 9 equals to 3. Why? Since 3 into 3 means the number which are in square root. What about root over 25? 25 obviously 5. Why? Since if we multiply 5 into 5, then we will get back this number. Then what about root over minus 9? Is root over minus 9 means it will be 3 or it will be minus 3? Which one is true? Is anyone true? Check by this previous concept. So if we declare that root over minus 9 equals to 3, then you have to verify that 4 into 4 if multiply, then we will get back 16. 5 into 5 multiply, then you will get back 25. Then is it true that 3 into 3, if you multiply 3 into 3 two times, then you will get back minus 9? No, 3 into 3 means 9, but not minus 9. So we can't consider this as the solution, so this is wrong. Understood? But next, what about minus 3? So check, if you multiply minus 3 and with minus 3 and minus 3, then is it, what is the value of this? Again 9. So if you multiply minus 3, then we will not get back this number which are inside the root over 9. Then we can accept this number solution? No. Then what about root over minus 9? This is the main question. Then what is the value of root over minus 9? Is it possible to solve? Then mathematics fails there. Mathematics stop there to calculate the value of root over minus 9. Mathematics stop there his journey? No. From this problem, a new branch of number has been started, and that is called imaginary number. Okay, how mathematics try to start the journey of a new number system. It started. So how the journey is going on now? How they control root over minus 9? Actually, they have tried to express root over 9 as much as small. How? Look at the board. They have used root over minus 9 equals to root over minus 9 can be written as 9 into minus 1. Is it true? We can distribute the square root over the factor of inside the square root. That means this is nothing but root over 9 into root over minus 1. Root over 9 means 3. And what about root over minus 1? Actually, they have given a standard symbol. They have used a standard symbol for root over minus 1. Now it is impossible to make it small. Minus 1 is the small least part. So they have used this number by standard symbol I. What? By I. Okay. By symbol. Keep it here, that I. So what is the value of root over minus 9? Root over minus 9 equals to 3i. Okay. Where I equals to root over minus 1. Okay, so many letters are there, A, B, C, D, E, F, G, so many alphabets are there, but why they have used here I? I stands for imaginary. This is the first alphabet of imaginary number. Understood? So what is the value of root over minus 9? No, 3i. Okay, then what is the value of root over 16? Root over minus 16. Hope you get the idea. What about root over minus 16? Minus 16 can be written as 16 into minus 1 equals to root over 16 into root over minus 1 equals to 4, and this means I. So what is the value of root over minus 16? The value is 4i. Okay, and all over world knows about I equals to minus 1. They knows it. Okay, on the basis of this concept, a branch of mathematics has been established, and namely complex number. From this, the journey of complex number has been started, and till now it is going on. When you will go to the higher class, you will understand then what is complex number, and there is no difference between complex number and vector. I will not go into that part. Okay, so this is the concept of imaginary number. So what is the main thing here? The main thing is a number within square root. If negative number is there in the square root, then that number must be an imaginary number. What? Root over minus 3, imaginary number. Okay, root over minus 5 imaginary number. That means inside the root over, if a negative number is there, then that number must be imaginary number. Is it clear to you? So I am writing that part. So write in detail that you can note down all this information. If you are interested, highly interested, then you can note down. Okay. So imaginary number means what? If inside the square root, if negative number is there, negative number, then it is imaginary number. Okay, then the number is imaginary. Actually, they have taken I equals to root over minus 1. The value of root over minus 1 till now, mathematics fails to compute the value of root over minus 1. Okay, but they have started journey. I equals to root over minus 1. So this is the concept of imaginary number. So if you try to remind all the classes, then what? Root over minus 5 means imaginary. In the square root, a perfect square number is there, then must be rational. If root over a non-perfect square number is there, then it must be irrational. Okay, so this is the concept of imaginary, rational, irrational on number system. Okay. Hope you get the clear idea. So next I will discuss about nature of the roots. Now actually we have to discuss this part, otherwise you could not understand the nature of the roots. That is why I have discussed this part. Okay. Okay, I will discuss the nature of the roots in my next video. Otherwise, video will be very long. Okay. So in my next video, directly I will discuss about nature of the roots. Okay. Hope you get the clear idea, and
please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.